Okay, guys, welcome back to the channel. As you can see, we do have a very special guest, and today we do have Austin Griffith, and we're going to discuss development, how to get started with Ethereum programming, how to do it quickly. And Austin is the guy. It is the person to discuss this because you do tools, you do code that makes people able to start their projects quickly. So please explain who you are and what you do.
Word. Yeah, I'm Austin Griffith, builder in the space. I kind of got started at hackathons, so I know what a hackathon stack needs to look like. And I know that like if you have to spend half the hackathon setting up your stack, then you're going to be at a huge disadvantage. And I've kind of built this to be Scaffold ETH is kind of what we're talking about today. I've kind of built Scaffold ETH to be kind of a full decentralized app where you have hard hat on the back end, you have React on the front end, things are wired up, but it zooms you in on, I can edit my Solidity in a quick development loop and I can see feedback and I can poke at my contract and I can kind of learn Solidity. But once I've done that, I basically have an app that's standing up with, you know, wrapped around my contract that I can start making into whatever we want to build, right? So we can dive into. Right. You go first. Let me know when you want me to share screens, or we can. I will
do that.
Okay, cool.
And just to highlight the problem that this tool is solving, many people when they start programming in Solidity and they come into the blockchain space, they learn how to do smart contracts, and then their biggest question is, okay, how do I make a website that talks to this data structure that I have now on the blockchain that I've programmed with Solidity? But with your setup, and we're gonna show exactly how you guys can use it in order to build your dApps already today. With your setup, it's just installation, very easy to install, and you edit Solidity, everything is live already. You have the website already reflecting all the changes, and you have this very, very quick development feedback, because normally what people will do is that they build smart contract, then they figure out how to connect it, and it's a very long time in between. But here it's optimized for learning, optimized for quick execution and quick development. So please, let's build something. Let's build something using Scaffold ETH, and let's show this in practice. And of course, it's all open source, guys. You go to GitHub, you quickly install it and get going.
Okay, here we go. Let's see. So I started at Scaffold ETH. I think if you just Google Scaffold ETH, there's a scaffoldeth.io, but that just drops you into the repo. And yeah, you just go, there's plenty of stuff here to learn from, but the quick start is the best place. Make sure you have all your Node and Yarn and Git, the usual stuff. But here is the installation process, and you'll bring up, you'll bring up your React dev server, you'll bring up a hard hat node, which is your local blockchain. And then when this is our deployer terminal, and we can just do a yarn deploy here, and that's going to compile our contract and it's going to push it over into the front end. So we'll see this contract get deployed. That goes to our local chain. Then the artifacts get injected into our React app. See how that hot reload happens? Let's do it again. Let's keep going, right? A nice tight dev loop. So this is going to be 9FE. We see that get deployed, and then hopefully we see that over here. Cool. And that's what it's about, is like being able to say, okay, let's create uint. Make it a uint8 public counter, right? I do this a lot, this example, just to show off, like, okay, now we have a counter in you kind of called it this data structure. You build this fancy, expensive backend that can do storage and execution, and then you have to build the front end to kind of deal with that. And if you build them kind of in parallel, a lot of like other things can shake loose, and it kind of helps with inspiration and stuff too. Okay, now we've got
basically what we're seeing now is this smart contract on the blockchain. This is running on your local blockchain, but of course you can deploy it on the mainnet, testnet. And if you go to your web app, your React app, you see all the variables in real time popping up in the interface. So if you bring that up again, the actual web app, we see like the counter, the purpose, and if you look then in the code, you see the purpose and counter being the variables in the smart contract. So you can very quickly get the connection between front end and back end.
So here's the extra stuff.
Sorry, yes, but back end in this case is the smart contract, of course.
Yes, yeah, and it's really, if you're a good developer getting into Ethereum, it's a good mental model to say, this database is, this back end is like a database. It's just slow and expensive and asynchronous. And what we really mean by asynchronous is like when you write to the database, it's a transaction that goes into the mempool that might get mined and might not, right? And you have to wait for that to get mined before that state change happens. But in terms of reading, you can read from any node on the network because all like 10,000 of them have a copy of your smart contract, and you can ask any of them for the whatever the purpose here is, right? We have a purpose, which is some storage, and then we have a set purpose, and we can do a hello world here. I think the point of showing this is showing, make sure we can grab some funds from the faucet, hit hello world. There we go. So the point here is if I hit hello world, we can see it over here. We get a nice console log from Hard Hat. And if we go look at that in our code, we bring in Hard Hat console log, and then you get a nice console log there. So when you're building Solidity, sometimes it's complicated. You're trying to figure out what the heck is going on. You can throw a nice little console log there and get that out.
But so, Austin, where is MetaMask? Because here you have a wallet that just signs everything by itself, by default, because that's what I like also with this example. There's no MetaMask, there's no signing, it's all instant.
Yep, exactly. So same thing. There's no MetaMask yet. There could be though. There's a connect button here, and if I wanted to bring my MetaMask in or any other wallet connect wallet, I could do that here. But really, what I'm using is a burner wallet. When you land, let me open up a new incognito window and go to localhost, and we'll see up in the top right we're going to have a different address, 2BCC versus D7. And if I close that, let's just go ahead and grab that, close it. Let's open up another incognito window. We should have a new address. Like it's in local storage, and that's very ephemeral sometimes. If you close an incognito window, bring it back, that local storage is gone. But so this character can grab some gas. So this is a blue guy. This is D7. So I added in that counter, right? Let's look at that. We added in a storage location called counter. We set it to 5. I added in a function for decrement. And let's go ahead and click this button a few times until we get to 0, and if we subtract 1 from 0, we went underflow, right? so we underflowed that variable, and if we wanted to kind of say, well, what happens if that's a uint 256 instead of a uint 8, we can quickly iterate on it. We can test our assumptions, we can put it into the Solidity, we can yarn deploy, and it's just going to show up over here in the front end, and then we can try decrementing it again, and we should get it like a really, really big number. And I'll do it with this character here. So decrement, here we go. Boom! Giant number.
And just to add a funny story, when people think about how smart contracts are built or how all of this cryptocurrency work, I mean, this is literally it. You have a number, you add to it, you subtract from it. When somebody sends tokens to someone else, they get subtracted from the balance of the sender and get added to the balance of the receiver. But also this underflow, overflow, we've also had insane bugs in some contracts that are badly built. And when somebody goes below 0 in their balance, they suddenly become a multi gazillionaire because it underflows, overflows. So these kinds of things we have standards for in order to avoid in the space, of course. But I just thought it was funny story when you showed this underflow, overflow.
For sure. And it's like you just have to kind of be cognizant of what those bits are doing underneath there. They're doing exactly what you told them to do, right? The code does exactly what it's supposed to on all the machines. And by the way, in Solidity 8, I think underflow basically throws an error now. And before that, contract developers would use the safe math library, where if that underflow happened or overflow happened, it would just throw an error. Okay, so we're going to do a little bit. I'm just going to add an owner in here, and then I'm going to require that the message.sender is equal to the owner, and I'm going to say not the owner. So this is kind of like one of the big powers of Solidity, is being able to write these simple rules in here and track. So we're going to track some arbitrary owner, and then we're going to make sure that only the owner can get in here and set the purpose, and we're deploying a new contract, right? Just 1 or 2 lines of Solidity, we've completely changed the mechanics of how this smart contract works. Instead of anyone getting in and being able to set the purpose, now it's more like an attestation where we're the owner and only we can set. And let's make sure. And then how do we test the bad guy case? We'll bring in an incognito window. We'll go to localhost. We'll give them some money, and this should not work, right? Hopefully we get yelled at for not the owner. Okay, so we've like tested that rule. Nice. We kind of audited to making sure that line works. Next thing I usually do is turn this
just
in.
to
Yeah, go
highlight
ahead.
once again the value of this framework. You get all the error handling, all the error messages from Solidity already animated with some kind of error message pop-up dialogue like we saw just a second ago. And of course, when you're starting your project, you want to have this from scratch. You don't want to Google, hey, JavaScript animation library and figure it out. You have everything here already.
And in this case, so that notification is popping up locally, but as soon as you go to any public network, it's going to use Block Native's notify.js, and it'll link to the Block Explorer on whatever chain you're on. Okay, so I added one separate line, and I changed this, and instead of making the function only one owner can hit it, now I set it up so it's a public function that anybody can hit, can call, but it's payable, and we're going to require that someone passes in some money. So we changed just one little line of code. We changed it from an attestation machine into more of like a vending machine for writing some purpose here, right? So now anyone can say hello world, but they have to send along a little ether to go with it. I don't have that much. So let me grab this. I need to go to the faucet and send myself some money. There's some money. So now I should have plenty of ETH to send in 0.1. And here's a little gotcha. In this framework, this is meant for the developer. And I don't automatically take it from ETH to Wei. You have to hit this little button as the developer to know that conversion is happening, and then you hit send. If you don't hit that, you're going to get an error. And of course, you don't want your users to do that, but this is there for you to kind of get a feeling for how your smart contract is going to work. And eventually, you'll carve all this stuff out and build an example UI. There's a bunch of components here that help you. Just to lean into that a little bit, like every hackathon I ever went to, I always needed an address input, right? I needed to be able to say Vitalik.eth and get his address and have a nice, right? So I've got ENS resolution. I've got blocky previews. I've even got like a little scanner. If this is on mobile, you could pull up your QR code scanner. Same thing here. If this is a $12,000, I guess, that can switch back and forth between the amount of ETH, and it's either in USD or not, and it's always tracking the price of USD. So just like really handy things that I need in every build, we just kind of packed into this so you can kind of pull it off the shelf and use it. And it's really this dev loop right here. Let's learn, and I even have it on Scaffold ETH where I talk about how to kind of get into Solidity and the different topics to cover. But basically, you're going to Solidity by example. You're grabbing a mapping, you're copying that mapping over here, and you're pasting it in, and you're doing a yarn deploy, and then you're looking over here to make sure that mapping shows up. And that's that loop that you want to be in, and you're just like learning all the new concepts. Once you have mappings, learn structs, learn payable functions, learn modifiers, and it's like listed out there, and you can copy and paste them in and get an idea of like, oh, this mapping, if I were to say, let's see, my map, and then we'll put in owner, and we'll set it to 5. Let's see. I'm not sure if this is going to work. Let's find out. And then we should be able to check my map for my address, and it should be 5. Let's see if it works. And this kind of like testing assumptions, building it out. Okay, so if we grab this guy's address and we paste it in here, we get a nice preview, we hit send, it's 5. See that 5 there? It's kind of hard to see.
And for all of you guys who are learning Solidity, and this may be the first Solidity code you see, this is also how tokens work. You have a mapping, and then you just map address to how many tokens they have. So in this case, this mapping could be balances. And now this address has 5 tokens in this case.
Awesome. That's a great way to put it. After mappings, I think I have you learn arrays, and then structs, and then arrays of structs, and a bunch of other things sprinkled in there like modifiers. But really, once you can deal with arrays of structs in Solidity, that's about as advanced as most of them get. Like that's like 80 or 90% of all the contracts I've seen. Like you've said, like a token is basically everyone's balance and a function to be able to transfer from one person to another. And that's how a token works.
What I love about Solidity and Ethereum is that it really demystifies finance, because from the outside, it may seem that banks are doing something revolutionary. But at the end of the day, man, if you know a hash map or you know a mapping, you can build your own token, you can build your own smart contracts, your own financial primitives. And that's the best empowerment that I think we're seeing right now, that all devs have now this financial sandbox. They can build whatever they want. This is a development environment like if a sandbox, you can program your own exchange, your own derivatives, whatever you want, just with simple building stones. If you know arrays, you know hash maps, you know the basic building blocks of a programming language, you're ready to go. And as you can see, it looks like JavaScript, it looks like Java. There is nothing too complicated to get started and get going. As with anything, it is difficult to master, but it is easy to start and easy to get results.
That's a perfect way to say it. Solidity is easy to pick up, but very difficult to master. Building a secure smart contract system of many different smart contracts communicating with each other is like, you know, there's like 4 people in the world that can do that right now. Yes. Well, there's more, but like any old developer can just pull this thing off the shelf and build stuff, and it's built for that dev. Okay, and then one little thing here. So I did Hello World. I paid some money. I'm going to say Hello World 2, pay some money. The thing that is neat here is we end up seeing that, oh, that smart contract ends up getting value. And I kind of start using this mental model of like, Ethereum is the greatest massive multiplayer RPG ever created, and each of these players are players, but now, you know, even the smart contract is a player, right? So all the players are sort of interfacing with these robots, and then the robots are all interfacing with each other. Right. But we've done something bad here. We've locked these funds up, and what you need to end up doing is writing a quick withdraw function, right? So people have paid into this contract, but we have no money, no way to get it out. So we could build like a withdraw function here where we could make sure that we would use this require statement that we used back here. It was the message.sender is equal to the owner or something like that. There we go. And we just set another rule and we say, okay, if you're going to call the withdraw function, we're going to make sure that you're the owner. Ooh, this probably needs to be enough. There we go. And then if it is, then we'll just say message.sender.transfer, and it'll just be what, address this dot balance. There we go. So if you call the withdraw function, we're going to double check that you are the owner. And if you are the owner, we're going to withdraw the funds from the contract to you. Uh-oh, I've made it. Oh, we got rid of my map. Let me get rid of that. There we go. This is some rapid Solidity prototyping here, right? Just kind of throwing it in, trying to figure out how it works, tinker with it, poke at it, test assumptions.
Perfect.
All right, and then if I say hello world or whatever that is, and I do 0.1, and we pay for it, we should see that the contract gets a balance. There we go. Now let's come in as the attacker and try to withdraw, and they shouldn't be able to, right? Let's get some money from the faucet. Yep, if I hit withdraw, we're going to say not the owner, not the owner, not the owner. Then if I come over here and try to withdraw, we should see the money clears out and goes into my account.
Nice.
Cool.
So that's also like, a very important point to iterate, that on the Ethereum network, you can have money, but also programs can have money. And what we're looking at right now on the screen, this code, it's a small program. It handles money. It has money that we send to it. And then there is logic how you can withdraw money. So this withdraw function. So if the withdraw function is not there, nobody can take out the money. Or if there is no logic that follows what withdraw function wants you to follow, then also nobody can take money. So this is very revolutionary from the internet perspective, that we have programs on the internet that hold money, and they will not give it to you unless you can run the withdraw function and it actually completes.
And these programs are decentralized. I feel like there's a big, like when we think of what it took to build Bitcoin, it took you know, you need all of that hardware, and you need that whole network, and you need that whole consensus and proof of work and all of that to keep track of a ledger of who's sending money around. Like if you want to decentralize a currency before Ethereum, you had to like fork Bitcoin. You had to figure out how Bitcoin works. But the real innovation of Ethereum is that you can innovate on top of it. It's that substrate where thousands of nodes are all like, they can all be adversarial and they still get along because they trust the code. And all those nodes allow you as a developer to throw some app into code like this and deploy it to that whole substrate. And then that code, that program, that little robot runs on everybody's machine and gets the same result every time. And we come to a consensus with proof of work right now, but proof of stake coming soon. This is my ETH2 node right here. I don't know.
Wow, nice.
Yeah, I don't even know if we can see this video. Hopefully we'll be able to see it in the thing. I'm hoping so. Okay, so I think you said maybe you wanted to look at some examples. Like once you dive in, there's probably like one last thing here, and it's probably deploying it to a public network. Like let's say, or even less than that. Let's say we're setting our purpose. I'm going to pull out the withdraw. I'm just going to let anybody set the purpose. We'll just make it very public. And let's go ahead and deploy that. I'm going to pull the hard hat stuff out too, since we're going to go to production. There's no reason to bring that console log stuff with you anymore. I'm going to do one more deployment. Basically, I just want to make sure this works, and I can do a test, and I can set the purpose. Whoops, test, set the purpose. Okay. And so eventually, let's say we have our smart contract working the way we want it to. This is actually what we want. We want to store the purpose and let anybody set it for some reason. Let's say it's working well. What we do is we build out our own UI, right? And we can move over into the front end now. At first, the only piece of the front end that you're using is basically this. It's pretty long, this contract here. So there's a contract component, and that's what gives you this here. So if you bring in a second contract, you just bring in a second contract component, and you have this nice interface there. But then eventually, you'll build a full UI, and you'll want to do some React work there, right? See that show up there. Okay, so let's just look real quick at the example UI. I have a ton of buttons and stuff, but if we just look at, it's exactly what you would think. There's like an input, and on change, we're keeping track of a state variable. And when someone clicks the button, it's going to do, let's see, where is the transaction? Right here. So there's this TX helper. And if you want to call, let's say we want to call the set purpose function on our contract. So it's going to be the write contracts. So you say, I want to go to my write contracts. I want to do your contract and then set purpose and then whatever purpose I want to pass in there, right? So very straightforward interface. And then it's wrapped in a TX that gives you a callback function. Basically, once the transaction's either successful or not, you'll get a nice little callback right there in line. And that TX, by the way, also is for the notifications. Go ahead. So
this is using Ethers, right? Or
yep.
Web3
Yep.
and Ethers. Perfect.
Yep.
So you have this instance of the smart contract, and then you can also write. So you've built this write contracts function that can add things to a smart contract, and you basically have all this logic done to send transaction, wait for it to confirm, and then get the confirmation.
Yep.
Nice.
Yep, and that write contracts just comes from so there's tons of components, but there's also a bunch of hooks. So we have a hook for, use contract loader, use balance, just a bunch of like things that we needed to use external contract loader, use a contract reader, use an event listener. Here, like a contract reader makes a lot of sense. It says, go to this contract and read the value purpose and keep it stored in this state variable. So anytime I want to read the purpose, I can just spit it out in the front end right there, right? And if I say hello here and I say set purpose, we should see that updates. Okay, so let's pretend like basically this is our whole app right here and it's working and we're ready to deploy this thing. So what you'll do is if you want to deploy, you'll do like a yarn deploy, and then you could do like -- network, xDie or Rinkeby or something like that, right? The problem here is on a public network, we're not going to have an address. You need to basically, when I'm deploying locally to this guy, I deploy using the 0 address or the first address on the node. The node comes up with a bunch of wallets that are pre-populated. Here I don't have that, so I'm just going to do a quick yarn generate, and that's going to make a mnemonic. It's going to keep it locally. It's going to give me a deployer account, and if I do a yarn address, I think it's going to, or yarn account, it's going to show me my account and give me a little like QR code if I wanted to shoot some to it.
Nice.
But let's just grab my. Where are we going? What's your testnet of choice?
Yeah, let's use Kovan.
Okay, let's go with Kovan. I like it too. It's fast. Okay, so let's send 0.1 Kovan to my deployer address. Okay, and I'm going to assume that's going to take about 5 seconds, so we're about ready. Okay, so here's on the back end, you could do -- network Kovan, or you can even just set it here. And I'm just going to set it here just so it's like kind of hard coded into my app. Now it's configured for Kovan. Yarn deploy, just like we were doing locally, but now we're deploying to a public network. And hopefully it'll take a little, it'll take like 5 seconds, right? It'll take a little bit here to load up. Come on, Kovan. Public blockchain. There we go. Okay, cool. So, and we could even go ask a third party, like a disinterested third party. Is there a Coven Etherscan? There is. And let's paste that address in there. It hasn't picked it up yet, but I'm assuming it's there. Yeah. And then, okay, so we pointed the deployer there, right? Now we need to point our front end. And it's just as easy as changing one other thing too. So at the top of your front end, there is a network, and it's currently looking at localhost. So when we go here, it's like, I can't find the purpose. I can't find the contract. I'm trying to read it from localhost. It's still trying to read from this guy. So if we change this over to Coven also, now we've kind of pointed both satellites at Coven. We've deployed our contract, and now we have a front end. Look at that. Our app is actually talking to Coven and ready to go. So I'm going to do a yarn build just to start preparing our static app. Right. So we've deployed our contract. Anybody can go interact with our contract, but now we want to build an interface and put this interface out there for someone else. And so just using the interface with Coven, I can write, hello, let's connect our MetaMask too, right? Let's see this work with MetaMask there. So I've connected my MetaMask. And by the way, if I'm on the wrong network, like let's put it on mainnet, it should automatically within Scaffold ETH yell at you and tell you that you need to be on the right network. So whatever network I selected there, it's checking to make sure I have that.
And, speaking about the networks and stuff like that, I think it's very important to know that this is maybe the most important piece of tech you can learn in blockchain space right now, because this is Ethereum, this is Binance Chain, this also applies on Polygon, this also applies on Arbitrum, Optimism. Whatever project that is really growing right now will be EVM based. And EVM means that it's exactly the same process for developing and deploying and running. So when I'm speaking to developers and I'm telling them that EVM is like HTML of blockchain, you don't even have to run it on Ethereum. Just like HTML and JavaScript, there are so many different engines underneath, and really how JavaScript started versus how it is today under the hood is very different. But the interface, the programming language is basically the same. So the same thing is with all of these processes. Even if you think that Ethereum, because many people say, no, Ethereum is so slow, this and that, it doesn't matter, because this kind of knowledge, this kind of framework, this kind of tool can be used anywhere. And it's very likely that it's going to be EVM, that is going to be the programming interface and the execution environment on that blockchain, because that's what most developers know right now. And also, if you think about it, maybe EVM is not the most ideal way of building dApps and running a blockchain, but so is not HTML and JavaScript and CSS. Right. I mean, what a mess of tech we have on the web. HTML, CSS, JavaScript, PHP, no, it's a mess, but it is like that because people use it. So I think it's going to be EVM that is basically HTML of crypto and finance in the future, really. But the most important thing here to understand is that this is cross-chain. It's not only about Ethereum.
I think that's a great way to say that. And I scrolled through the networks there. There's a ton of networks, but you'll see there, we just made a transaction on Coven. It said it was successful. The purpose is updated. So we've tested, we've got our local front end talking to Coven, but what we're finally waiting for is once that's built, we can do a yarn surge, and I can push this up and I can send you the URL. Let's do surge. What are we going to call this domain? Perpy? For purpose? Let's see if it goes. Let's see if it lets me have that domain. Oh, it's going. Okay, so then if anybody out there wants to, they can go to perpy.search.sh once this finishes uploading here, and you can connect your MetaMask, and you can set it to Coven, and you can set the purpose over here in this example UI. So we were able to go from tinkering with Solidity to now anyone can go to perpy.sh or .search.sh, and we've deployed a decentralized app, both the front end and the back end. And if they go here and they say test and they hit go, oh, I don't have any, I have to connect something. Here we go. Connect one of my MetaMasks, set the purpose to hello on perpy.search.sh, hit go. There we go. We're just making a transaction on the public network. Cool. Fantastic. So that's like a fully, like that's from 0 to 1. Basically, we've learned, we've tinkered with Solidity in our Your contract. We've deployed that contract to a public chain, and then we've kind of built out a small little front end. But you can see how you would tinker with this for a little bit, and then end up building out your front end. Like, okay, what are the important things? I'm going to set up a hook to read those things. I'm going to show off, display certain values, put in some certain buttons. We could look at these buttons real quick in the example UI, but I think what you wanted to hit on next is just like, what's next? Sort of like once you're up the Dunning-Kruger and you've got solidity, what's next, right? Yeah.
Exactly. Because I think many people, when they start with Solidity, they start with guessing a front and going, they really see the magic and they get started. However, it is also the fact that you have so many high-level concepts in crypto. For example, liquidity on an exchange. You have to do a bunch of aggregation, a bunch of calculation on chain to even show that. Or how do you show all tokens for a user without asking each and every token smart contract? So these a bit more higher level concepts and how to query them. Let's discuss that, and let's get into this concept of subgraph, which I also saw that you guys have a button for. So let's talk what that is, why it's important, and how we use it.
Okay. I think that it all is based, like, we should start with talking about events, right? So smart contracts can trigger events, and these events are basically just used for your front end. It's like really cheap smart contract storage, and the gotcha there is one smart contract can't read the other smart contract's events. So it's just for us, it's just a way for the chain to sort of emit this data that then we can go read. And we have this happening here. As someone sets the purpose here, and they hit set purpose, and they trigger a transaction, then down here are these events. So we're listening for the smart contract to emit these events. There we go. So we have a use event listener hook, and it's just listening for those events, and it's listing them here in this list. But this can get overwhelming, right? Imagine, like, this is great for me, or even if this was like a decentralized bank and every deposit and withdraw, you wouldn't just show someone's balance, you would want to show the record of each deposit and withdraw. But if this was something where thousands of people were interfacing with it on a daily basis, and we were showing all the events of everything happening, it could get really, really big. And that's what I jump over to Nifty Inc., because this was kind of the reason why we had to switch to using the subgraph, is because if we want to query all of these things, we basically would have to query, like, there's probably been, I don't know, maybe 10,000 of these things made, or thousands of these things have made. We would have to listen to all those events and then parse through all of that on the front end. And it just doesn't make sense to do that. So once you start with your contract, make sure you have events for everything, make sure it's displaying and you're using it like this to prototype. But then there's like a step up where you could go to the subgraph, and you can kind of have a middleware layer that reads all these events and then keeps them for you in this middleware database. But I think even more, we should kind of like slow pitch this onto the Moralis stuff and talk about how maybe your stuff could fit in here as another option, or even like probably fit in this app.jsx, where we would bring in some Moralis stuff. Yeah,
exactly. And I mean, the whole idea with Moralis is that we've all gone through this process, and we also run Imontech Academy, and we see all of our students go a similar process, that they come into blockchain, they learn all of these simple things, but then they think that everything is simple, but they cannot do it. For example, how do you get all tokens of a user? Like we said, you basically have to query all the token smart contracts. Or how do you log in a user cross-chain and keep all of their transactions cross-chain? So that is why we have this Moralis API. And if you go to crypto login in the menu, you see that we've also done a wrapper around the Web3 and Ethers, which is moralis.web3.authenticate, which will bring up MetaMask as Web3, as Ethers. But when the user signs in, the address gets synced, and we take all transactions on all blockchains that this address that the user is using has been active on. We get all of the transactions, all of the NFT balances, all of the token balances, and we give you that data already from out of the box. So if you go to our landing page, which you saw previously in your other tab, right there, exactly, you see as soon as you authenticate, you get the address, the transaction. You can even add an email and the name, like we see in the picture. You can send emails to your users. So this is a mix of both off-chain and on-chain profiles. And on-chain profiles, it means that you get everything about the user on all chains, all balances, all transactions, but also you can have a user profile with many different addresses. Because right now, in many dApps, you have a user, but a user can have 10 addresses. All of us who are using a DEX, most likely we use a lot of addresses. Why? Because otherwise everything you do is on-chain in one address. And so many people, what they do is that they have 15 different addresses on different chains. And how do you calculate taxes for all of that? Well, The tax app better have a user profile of you where you can collect everything. So this is really a layer on top of your Solidity. And this is perfect integration into Scaffold, which we hope to integrate into your project, Austin, because we think it's amazing. And it would be even more amazing if we can offer Scaffold to our community and they can get their smart contract, their UI ready, and also they get all of the power of Moralis, for example, with all of the user things, how to get all the user information, but also more higher level things. And let me also discuss a bit what I mean when I say higher level things. I mean, for example, that when you have transactions going from user to user, that's very basic. But then on top of that, you can calculate the volume. What was the daily volume in a certain smart contract? Then you need to basically calculate all of the sum of all of the transactions, and then you get the volume. And then based on the volume, you can calculate even further. You can calculate liquidity. You can calculate a lot of these higher level concepts. But to get to these financial higher level concepts, you at the end of the day have to start with just transactions. And to index all of this on a chain like, for example, Binance Chain or Polygon, where blocks are coming each and every 3 seconds and there's thousands of transactions in one block, that's very, very compute intensive. And it's a whole big data system you have to build. And that's also what Moralis offers. You can watch any event, you can calculate liquidity, you can calculate whatever you want. And it's all instant, all simple, all instant, easy API, easy SDK. So that is where we feel that we're feeling a big need, because with Moralis you can literally build whatever you want without worrying about indexing or building this infrastructure that you normally would do, and it's so fantastic because we truly see the magic in people's eyes when they see that everything is one line of code. And this is how it should be. This is how it is in Web 2. In Web 2 you have so many frameworks to manage your user across different identities. You can log in with Google, with Facebook, with email password. And it's so easy to track that. But in blockchain today, it's not that easy. And to even, have all of the history in an easy, accessible way. So yeah, this is Moralis, and we're looking forward to building a branch on Scaffold where people can get started with Moralis also by just, downloading Scaffold. And I think what's really missing from the space today is how to get started quickly for developers. Most developers are not even here in crypto. We have right now maybe 100,000, maybe 200,000 developers in crypto, and worldwide there is 28 million. So it's less than 1%. So of course, whenever people search how to start a blockchain app, they should find Scaffold. They should be able to run it and get their environment. And also with Moralis, get all of their user data quickly, and have a database of users and do different aggregations and calculations. So this is the future of development that we're foreseeing that is coming upon us.
One thing I wanted to show is this is called the Punk wallet. This is a product that we made where your identity is tied to Punk, and it's deterministic. So it's always going to be. And then if I copy this Punk's address and I paste it in over here, we see the nice preview, right? The address becomes that Punk face, and I can send, maybe let's send $1 to this Punk, right? And I'm sending it on my local testnet. We're running on localhost here, which is a neat little piece of the product. But the problem here is if I wanted to show transaction history, it would be a nightmare. It would be
right.
It would, and I did that like back in the day with the XDAI burner wallet.io. I think it shows transaction history. Oh wait, there it is. Yeah, it shows transaction history, but the way it does it is it basically looks at the current block, looks at all the transactions in the current block, looks to see if this address is there, and then works backwards. Yes. The front end basically does it all, and it loads it, and it takes forever, and it was a ton of work.
That's also why all dapps have some kind of backend, and that's also why we call Moralis that you can build serverless dapp, because with Moralis you don't need a backend. You get everything from our SDK, and we do all the heavy lifting. I mean, another such thing is to calculate, if you're looking at an ERC 1155, is to know which tokens are burned and not burned. Because you don't know if you don't go through all transactions and don't look at every time somebody sends to 0x0 address. I mean, that's the only way to know which tokens are still alive and not. And that's why you basically need to have your own index of all of this. And in some ways it looks easy because you see Etherscan do it. You see Etherscan show all transactions, but you don't really understand how much complexity is behind. Or you see, for example, OpenSea or Rarible do it, and you don't really. And you as a developer, you feel, oh, but that's so easy because it's so standard. Everyone is doing. Rarible does it, OpenSea does it. But if you only use Ethereum, only use the basic tools, it's very difficult. And that's also why Moralis is there to get you all the same features, all the same tools, all the same infrastructure that all the big dApps have. You get them for free, completely out of the box with a simple SDK.
Awesome. That's a good shill, man. You've been out this for a while. Let me jump in. So let's say you've got your app built, you've got Moralis in it. You're ready for production. You deploy it out there. Throw it back into these branches because we have so many cool branches. Like, wait, I don't even know what we're looking. Let's look for Chainlink. There's 4 different Chainlink branches. Let's look for commit reveal. There's 3 different commit reveal. What about like a bonding curve? There's 2 different bonding curves. So there's just so many different branches of things that you can look for. Search for them here. If you go to branches and go to active, you can see all the cool stuff that we're working on. And I just wanted to dive into the build guild real quick. This is kind of like the next step. So like as a builder, as you're building components, if you're looking to build things, if you are building things with Scaffold ETH, we're basically funding developers. There's a bunch of developers that I stream ETH to for building on Scaffold ETH. And so like that, but with the North Star, their goal is to basically just build cool branches of Scaffold ETH that are there's that punk wallet there that are, let's just grab the simple NFT example here. So it's going to set you up with an NFT contract, right? You're going to have a collectible. It's going to set you up with a front end. It's going to show you like step by step. Here's how you set it up. Here's how you deploy your NFTs. Here's how you mint your NFTs. You can send them around to different addresses, kind of like that whole tinkering with it and playing with how the app works. And so the build goes like just like a layer of incentivization on top of all of it. But just look for all these branches. If you go to Build Guild, you can type in NFT, see all of our NFT projects. So lots of fun stuff for developers between Scaffold ETH and Moralis.
This is perfect for our community and our project as well. Why? Because we need a boilerplate, basically bootstrap for Moralis, how to get started instantly with Moralis. And of course, we could build ourselves, but why? Because you guys are building each and every day, and we just have to maintain our specific integration and our specific part. And you guys will continue developing the UI examples and so on and so forth. So it's fantastic. And that's why the incentives are so aligned with your project and so many other projects like ours, for example. And so to round this interview off, what do you think will happen to other blockchains? Do you see any kind of development growth anywhere else outside of ETH? Personally, I have a bit hard time seeing that, but also it feels strange that it will not be like that. That it will basically, it is ETH and that's it. It feels too simple. Do you think that it will be like that, or you feel that something else is growing that we don't see yet, but we should be paying more attention to?
I think that you dug into it earlier by saying EVM compatibility. I think that there probably are, and we saw like a couple other L1s, some side chains, some other things. Like we see competition to ETH as the degentrification is happening and people are spilling off into these other chains. It happened and people were competing for that spill off. But the key piece to being able to compete is to be EVM compatible. And that's what all these tools are, is EVM compatible. So I do think, and just like to credit other people that aren't EVM compatible, I think there are use cases for those. Flow comes to mind. Like that seems like if you wanted to create an NFT chain for a specific use, like maybe you could create a blockchain that's like fitted for that. But the way Ethereum is just basically a substrate for innovation, right? It takes care of we have a bunch of protocol nerds that figure everything out and get that thing working really well. So a product developer can drop in and start building a product that people can use on top of that substrate. And it's going to be decentralized. You're going to have good good tools coming into it. Finally, it's been a while. Like it was hard to build in this space. Like even now, me showing off console log earlier, like it was like we
didn't have console log. Exactly.
Right, exactly. Yeah.
No, and I usually also compare this to the iPhone, because what if iPhone came out and you could not call all the older phones? It would be completely useless. But iPhone was backwards compatible with all older phones, and then it added its own innovation, and then it took it from there. So it's very important for new tech to be compatible with old tech, and maybe potentially in the future it will flip it. Also, if you watch Andreas Antonopoulos, he has a very good analogy with Bitcoin. That Bitcoin, in order to use Bitcoin still today, you need to use the financial rails of the past. You need to do bank transaction, KYC, this and that. And that's because always new technology has to use the old infrastructure before it flips. So in the future, everything will be on Bitcoin, on Ethereum. And this is like it was in the past when cars were a new invention. You still had to drive them on the muddy road, and it was horrible. People said cars will never succeed. Look, it cannot even do this muddy road, and the horse, it can jump across the muddy road so easily. But then it flips. Then the infrastructure flips. Now horses go on asphalt. So the same thing will be with Bitcoin and banks, that banks will be running on top of crypto networks. And if somebody is to flip ETH, they have to first run on ETH, like the cars on the muddy road, and then potentially they can flip it. So that is a good strategy that somebody could use. But I don't see that on the horizon even right now. But if it happens, we will be ready for it.
Exactly. We're product builders. It's about putting something in someone's hands and having them use it, right? Getting users and having them like have a delightful experience and do something they've never been able to do before. Awesome, exactly. Ivan. So, this has been fun.
Austin, thanks a lot for guesting the channel. Guys, go subscribe to Austin on Twitter, on YouTube. Go and download the Scaffold ETH, try it out, maybe even commit to it, because he will stream money to you. So if somebody wants to get some of that streaming money, what
basically the onboarding process for the Build Guild is to create something cool with Scaffold ETH and post it into the channel. And if you post something cool and you're building something cool, and usually it's like, okay, you built something awesome. Let's build something new. Let's build a generic component. How about let's build a simple NFT
which
auction?
Channel? The Discord channel or which channel?
There's a Telegram channel. It's like hidden in a lot of the GitHubs. There's a Telegram channel. There's lots of Telegram channels for different Scaffold ETH. Like even like Challenge 1 has its own channel where you would post your solution to Challenge 1, and then Challenge 2 has a different channel, and there's a Scaffold ETH channel, but there's also a Build Guild channel. So it's kind of like dump it in there. We'll find you.
yeah. And the thing is, it's like you said, it's the RPG. You got to be accepted into the guild. I played a lot of RuneScape in the past, so it's been good times, and it reminds me of that. So guys, go join. And Austin, thanks a lot.
Thanks for having me.